Jai Shri Ram to all. Today we are discussing about the concept of the beats in sound wave. So as we know that the sound wave are longitudinal nature. So longitudinal means the direction of the wave and the vibration of the particles of the medium is in the same direction. Okay, so it will produce the beats phenomena. So beats phenomena are produced by the two waves which have the nearly same frequency. A nearly same frequency means the f1 minus f2 is approximately in the range of the 10 hertz. The 10 hertz means the frequencies will be 2, 3, 4. Okay, so around the 10 hertz, that means 12, 13, 14 is also allowed. So let's say if we have a wave, let's say we describe the one wave, this one, this one, this one. So let's take this is the 1 second. Okay, so what is the frequency? The frequency is the number of the oscillation generated by the wave in 1 cycle. So one cycle complete, 2 cycle, 3 cycle, 4 cycle. The frequency of the first wave is the 4 hertz. Okay, similarly we make the another wave. It is 1, 2, 3, 6. Okay, so one cycle completes 2, 3, 4, 5, 6, 7, 8, 9. So the frequency of the second wave is the 9 hertz. So there is a difference in the frequency. The frequency difference is the most important condition for the beats phenomena. So when these two waves traveling in the same medium, so it will give the new kind of the wave. The resultant wave is in the form of that it will is in such a way that 1, 2, 3, 4, 5. So why I make the 5 such kind of the loops. So 1, 2, 3, 4, 5. Because due to the beat phenomena. So according to the beat phenomena, if the two wave, the one have the frequency f1, the another have the frequency f2, then the resultant wave have the frequency f1 minus f2. So for our case, the 9 minus 4 is 5. So we get the number of the beats. So this is not the beats. This is not a 1 beat, 2 beat, 3. The number of the beats is 5. Because the two waves is superimposed, that will have the frequency difference f1 minus f2 equal to 5 in our case. Okay, so what is the frequency what is the frequency difference? It will decide that the number of the beats in 1 second. Okay, so we will do the mathematical expression also. The main thing about the beat phenomena is that it is the phenomena of the frequency difference. So in this phenomena, the intensity of the sound is increases and decreases alternatively. So first it increase, then decrease, then increase, then decrease. Okay, let's use another pen. Increase, then decrease, then increase, then decrease, and increase and decrease. It means the phenomena of waxing and waning is known as the beats. Okay, the waxing and the waning in the intensity of the sound wave. Okay, so we'll do the mathematical expression. It's very simple because the main thing you should have to remember that the frequency is the different for the two sound wave. Okay, so let's say we have the general equation y equal to a sine omega t. Okay, and we use this expression to prove the phenomena of the beat. We will calculate the beat frequency, will come out the f2 minus f1. It's very simple. Okay, so let me have y equal to, let's say y1 wave is having the amplitude same a sine omega 1t, and the y2 is a sine omega 2t. So we'll taking the different omega because the omega is the angular frequency, and that is the necessary condition that the frequency of the two sound wave is different. So we can use this principle of superposition here. So y equal to y1 plus y2, and this is a sine omega 1 plus sine omega 2t. And from a very simple mathematics, we know the formula sine A plus sine B is equal to 2 sine A plus B by 2 into cos A minus B by 2. It's very simple expression we use here. So y equal to 2a sine omega 1 plus omega 2 t by 2 into cos omega 1 minus omega 2 t by 2. So let's rearrange this equation and we get the equation y equal to 2a cos omega 1 minus omega 2 into t by 2 into sine omega 1 plus omega 2 into t by 2. So this is the resultant wave expression. Okay, and here this is known as the resultant amplitude. Resultant amplitude. Okay, so this resultant amplitude depends upon the time. So it means it have the some greater value at some time and it will have the some smaller value at some point. Okay, so how this thing is dependent upon the time, that we discuss about it. Okay, the first thing is that if we talk about the maximum amplitude, okay, the maximum amplitude. So as we know that the maximum amplitude, how we can get the maximum amplitude? We can get the maximum amplitude when the cos omega 1 minus omega 2 t by 2 having the value 1. That is the maximum. So we know that the cos theta, so theta will become the n pi. Okay, so omega 1 minus omega 2 t by 2 is equal to n pi. So as we know that the angular frequency and the normal frequency have the relation omega is the 2 pi f. So we use here, so 2 pi f1 minus f2 into t by 2 equal to n pi. So pi is cancel pi 2. So we'll get the t equal to n upon f1 minus f2. Okay, so we will put the value of the n different value. If we put the n equal to 0, we will get t equal to 0. If we get t 0, so if n is equal to 1, then t1 is equal to 1 upon f1 minus f2. Similarly, n equal to 2, then 2 upon f1 minus f2. Similarly, n equal to 3, then 3 upon f1 minus f2. And if we calculate the time period, so we'll just minus 2 consecutive. So t2, t1 minus t naught equal to 1 upon f1 minus f2. Similarly, we minus this t2 minus t1, will also get 1 upon f1 minus f2. So this is the time period. So time period of the beat frequency. So here we use the time period instead of the time period. We use the beat period. So beat period is equal to 1 upon f1 minus f2. Okay. So next is the beat frequency. So beat frequency, we know the general expression of the frequency is f is equal to 1 by time period. It means time period is equal to 1 by the frequency. And we know the beat period is 1 upon f1 minus f2. So similarly, we can analyze here that the beat frequency will come equal to f1 minus f2. And as we discussed above, that the beat frequency is the f1 minus f2 in the case of the beat phenomena. Okay, so the main important thing that we should remember from here, that is the beat is the phenomena is occurring due to the frequency difference of the sound wave, and in this phenomena the intensity of the sound is increases and decreases alternatively. Okay, so this is known as the beat. So just around 2.